So what are we doing today?
I don't know. I got my test grade back. I don't have the test back yet, so I don't know what I missed. But I got a B on it, which is exciting.
Okay, good.
And then, I don't really know what we're going to do next in class, because today we had ACT testing, so...
Well, so when are you taking the ACT? You're a sophomore?
Yeah, today we took the practice ACT. My grade did, and then the seniors took the SAT.
Okay. Well, it's probably a little early for us to work on that, but certainly when you get to be a junior and a senior, we'll want to spend some time on that, just because that score is so important to your getting into college.
Yeah.
Probably as important as your overall GPA. So you want to put every effort you can into getting a good score on the ACT or the SAT or both, whichever one. Are you planning on going to school in state?
Yeah, in theory.
Okay. And Colorado generally prefers the ACT, I think, don't they, to the SAT?
Yeah, I believe so.
Yeah, I know. I went to high school in Maryland, and I never did take the ACT. I took the SAT, even though I was going to college in Colorado. So, okay. So what are we going to do tonight?
Well, the next chapter in the book is over products and factors of polynomials.
Okay, why don't we
But I
get
don't know
ahead?
if we're going to skip over or not.
Probably not. That sounds like a pretty key part of Algebra 2. If it was linear programming or matrices, I might say maybe they'll skip it until the end. But if it's factoring polynomials, that's coming up for sure.
Okay.
So why don't we look at some? Why don't we look at some of the exercises at the end of the first chapter or the first part of the first chapter on this subject?
Okay. So, has some notes.
Okay.
Then, it's talking about monomials, degrees and coefficients.
Okay.
Adding and subtracting polynomials.
Can you find some problems? Problems is the key as to whether, well, it's actually, for me, it's the key on helping you and teaching you.
Yeah.
I have a hard time when I have to just talk about concepts and stuff. The best way to really get somebody to understand something mathematical or scientific is to have them be able to do problems.
Yeah, so all the first stuff looks like things we've already gone over, like in school. So
Okay.
That.
Maybe you can find the first level that gives you a little confusion or difficulty.
So I haven't done multiplying exponents in a while, so maybe going over that.
Okay.
Like it has, here, this one would be okay, I guess. It's parenthesis 4a cubed times b squared and parentheses squared.
Like that?
Yep.
Okay. We're going to start from the inside. Whenever you have nested parentheses, it's a lot like nested radicals. Start from the inside and work your way up. So let's get rid of this first inside parentheses. What happens to that?
You get 4a cubed, right?
Well, what happens when you cube 4a? What do you get?
Oh, you get 16 times 4. Wait. So 64a cubed times b squared.
Right. Okay. And I don't need the dot. You don't use the dot anymore, do you, in a situation like this? Okay, so now what do we do?
Now you square the inside.
Okay, so the answer is whatever 64 squared is.
Yeah, that is 4,096. And then you add them, right? In the middle?
Multiply them. If you have a to the b raised to the c power,
okay, so yeah.
you add them in a situation like this. If I have a to the 3 times a to the 4, same base, different exponents, that's a to the 7. But this is exponentiation. This is not multiplication in this problem here. In other words, we have a cubed squared. Well, that's the same as a cubed times a cubed. So that's a to the 6th. So you want to multiply this times that.
Okay.
Okay, so that would be a to the 6th and b to the what?
Power of 4?
Uh-huh.
Okay. So okay. Okay, this one looks gross, so we'll do this one. Goodbye.
Good. That's what we're looking for.
X squared, and then inside parentheses, x to the power of k minus x to the power of k minus 1, yeah, plus,
End parentheses or not?
no, still parentheses,
Okay.
plus x to the power of k minus 2, end parentheses.
Okay. We're just supposed to simplify this?
Yeah.
Okay. So we need to distribute the x squared to each of these terms. Every term has the same base, which is x. So what is that equal to?
So 2x to the power of 2k?
No, just, in other words, when we have x times x, it's just the base stays the same, but the exponent you add.
Okay.
In other words, if I have 3 to the 7th times 3 to the 11th, that's equal to 3 to the 18th power. Different than if I have 3 to the 7th raised to the 11th power, that's equal to 3 to the 77th power. See the difference?
Yeah.
Okay. So that's the result of the first distribution. What else do we have? Minus.
So x to the power of 2 plus k minus 1?
Well,
So
we're gonna add 2 plus 2 plus k minus 1, which is the same as 1 plus k. And finally,
x to the power of k.
exactly.
Okay. Okay.
Once you get the 3 tricks of handling exponents, all of these problems actually become very easy, because all they become is addition or subtraction or multiplication problems.
Okay.
What is this? What is this?
wouldn't that be just b because you subtract the exponents from each other?
And that's the only three things we have to worry about with exponents, is when we're multiplying same base, when we're dividing same base, or when we're exponentiating same base. There is one other situation that's nice to know, and that is 3 to the x over 4 to the x. Here, notice the base is different, but the exponent is the same, so that is 3/4 quantity to the x. Or if I had 4 to the x times 5 to the x, again, different base, same exponent. So those are the 5 rules. Those 5 rules cover all operations with exponents.
Okay.
Okay, you got another one?
Yeah, so I got that, so moving on, multiplying polynomials. Okay. Okay, so it has some multiplying with the positive integers.
Okay.
So it has, okay, so in parentheses, a plus b, end parentheses, and then parentheses, a cubed minus a squared times b plus ab squared minus b cubed, end parentheses.
Okay. Remember when they taught you FOIL?
Yeah.
FOIL only applies to a binomial times a binomial. I really kind of don't like the fact they teach FOIL, because there's a better system to call it. And that is, you take every term and multiply it by every other term. In other words, and let's do it in a method that's consistent. Let's multiply that, multiply that, multiply that, and multiply that. And then multiply this, multiply this, multiply this, and multiply that. That's what I call every term by every other term. And that works with a binomial times a binomial. There's no need to teach anybody FOIL, because every term by every term does the same thing. The only place that you might get messed up doing this is if you do it out of order. In other words, if I do a times a cubed and then randomly decide to do b times a cubed and then a times this, and pretty soon I might miss one. You know what I'm saying?
Yeah.
So do it very methodically. So what's the result of starting with the top? If I list it over here on the left. In other words, let's start with the a times the a cubed. What do we have?
A cubed.
A times a cubed.
Yeah, so 2a cubed. A4. Oh, okay, yeah.
This exponent is 1.
Yeah. Okay,
Okay.
I totally do that.
Okay, so what's the second? The second expression.
So minus a to the third plus ab.
Well, just b.
That's just b.
In other words, when I multiply a times a squared b, I multiply this times this, and then that product is a cubed, which I'm going to multiply by b. So you just do it once, but you do end up multiplying every term by every term.
Okay.
Okay, and then what's our third term?
And then you would have,
I'll let you give me the sign.
oh, plus, right?
Uh-huh.
Yeah. And then a squared. Okay.
Hold it. What's the rest of it? That's just the a times the a. You also have the rest of it, which is b squared.
Yeah.
Okay? The fourth term?
Do you start with the b now, or do you go on to?
Well, no, we've only done the first three, so we still need to multiply the a times the b cubed.
So then minus ab cubed?
Let's keep them in the same order. In other words, let's keep our a in front of our b. Okay, so now let's do the bottom half.
Okay. So.
In other words, the b times the a cubed and every other term.
So then ab cubed
Plus,
ab cubed.
well, b times a, you meant b a cubed.
Yeah.
But I'm going to write the a cubed there and the b there, just to keep things in all the same order again. Second term, or the next term?
Okay. Minus a cubed times b squared. A squared times b cubed, sorry.
Times b squared.
Yeah.
In other words, b times b is b squared, and we're not multiplying the a, so it stays at a squared.
Yeah. And then minus.
We're on this one here.
Oh, yeah, sorry.
Okay,
Plus a times b cubed.
And finally,
then minus b to the power of 4.
Now, we need to see if we have any terms that we can combine. How many a's to the fourth do we have? Just one.
Yeah.
How many a cubes times b are there?
There is 1, 2, 2.
But they cancel because they have opposite signs.
Okay.
How many a squareds, b squareds are there?
There's 2, but they have opposite signs, so they cancel also.
We have a minus ab cubed, a plus ab cubed. They cancel. The only thing we're left with is minus b to the fourth. So essentially what they just showed us was the difference not of perfect squares, but of perfect quartets, or whatever you want to call the fourth exponent. In other words, if you started with the difference perfect powers to the fourth, it would factor into these two things. Wasn't their attempt, but it was a good problem to show that. Who knew?
Okay.
Who knew? I mean, if you started with a to the fourth minus b to the fourth, who knew that it would factor into that?
Ugh. It's a mess. Okay. Should we do another one?
Sure.
Okay, this one looks interesting.
This is going to help you to get ahead of your class. I think
Yeah.
it's going to help you a lot. Yeah.
Okay. So parentheses x plus y and parentheses squared times parentheses x minus y parentheses squared.
Okay. Now, we don't have the same base. Our base is x plus y here. It's x minus y over here. We do have the same exponent. So if I wanted, I could say x plus y times x minus y, and that whole quantity squared.
Okay.
Now the advantage of doing that is that it makes the math a little easier. Notice what x plus y times x minus y is. Do you recognize that?
Yeah.
What is that?
Wouldn't it just be x?
It's the difference of squares factored. So that when I multiply this by this, I'm going to get x squared minus y squared. Now, I'm going to do this problem two different ways just to show you that you don't need to know what I just said in order to do it. Okay? But this is perhaps a shortcut. Because now, when I go to square this, well, I square that, x to the fourth. It's minus 2x squared y squared plus y to the fourth. So I got the answer in 2 steps. Now let's do it the harder way. The way most people would do this, if they didn't recognize that, was they would go ahead and square this. What is x plus y squared equal to?
X squared plus y squared?
It's not really. No. This is a key one to know. This is one of the more, it's called a binomial expansion. And it's not x squared plus y squared, because notice if you FOIL this out, you get x squared plus xy plus y squared, which is x squared plus 2xy plus y squared. So that's what x plus y squared is. And just a piece of advice, memorize that, because you're going to have to do that so often over the next 3 years you won't believe it. On how many times they're going to want you to do a plus b squared. Now, maybe it'll be 3 plus 2y squared. That's the a, that's the b. Okay, so if you have a quick way of doing it rather than having to FOIL it each time, it's very helpful and speeds it up immensely. So memorize this one, know what x plus y squared is, and memorize this one, know what x minus y squared is. It's very similar. The only term that's different is the middle term, and it's only different by its sign. Notice that the first term and last term are still x squared plus y squared. Okay?
Okay.
Now, we're doing it the hard way, remember. So we still have to multiply this by this. So we have a trinomial times a trinomial. You do it for me. First term.
So, okay. X to the power of 4. Minus 2x squared plus or times y.
Notice that it's x cubed because we have an x squared times an x to the 1. All right, that's all right.
That's going to trip me up. Plus x squared times y squared.
Okay. So that's that, that, and that. Okay.
And then 2, okay, plus 2 minus, I guess, because it's a negative.
Well, now hold on. We're doing this times this, right? In other words,
yeah,
we're doing
okay,
that
so
one.
plus. So 2x cubed times y.
Okay.
Now minus 4x squared times y. Okay.
Uh-huh.
And then plus y to the power of 4.
Well, hold on. We still have, in other words, that was that term. Now we still have to do this one.
Oh, plus y to the power of 3.
Well, 2, in other words, we're still multiplying this middle term times this third term.
Oh, really? Okay.
Huh?
So then it would be 2x times y to the power of 4.
Okay. Now we need to multiply this term by all 3 terms. And then we're almost done. Still need to simplify it, but
x, or yeah, so x squared times y squared,
Okay.
Minus 2x times y squared.
Y cubed.
Oh, cute, sorry.
All right.
Plus y to the power of 4.
Okay. Now, we only have one x to the power of 4. Let's see how many of those we have.
Well, 2, 3, 4, but they all cancel out. That one, which is positive.
Oh, yeah, you're right. We have 2 of those.
Yeah, and then you have...
2 of those. I was trying to figure out where I've made my mistake because I knew that that wasn't in the answer. So, okay. So now how many x squared, y squareds are there?
There are 2.
There's minus 2 because here's 1, that's plus 1. Here's another one, that's plus 2. And then there's minus 4.
Oh,
That's
yeah.
net that. And then we have our final y to the 4th power. So we get the same answer. But notice how much harder it was
Yeah.
to do. That shortcut that I did the first time through saved like 10 minutes. But it's important for you to be able to do it both ways. Doing it the hard way like this was good practice on multiplying trinomials by trinomials, and it was good practice on knowing what a plus b squared is. So let me give you a little test. Square this. Hold on. Square it without foiling it. Square it knowing that a plus b squared equals a squared plus 2ab plus b squared. So square 3x minus 2y.
Okay. So it would be 9, right? Yeah. Okay.
What is a?
A is x. Is that whole thing? Okay, so it would be
So a squared is what? What is a squared?
9x to the power of 3.
2. In other words, if you multiply 3x by 3x, you get 9x squared.
Yeah.
Okay? So that's that term. Now
Okay.
we need 2 times a times b. What is that? And here, let me change this to a minus, just so we're on the same table here. Remember that when it's a minus b squared, the only difference is the middle term is minus. So this middle term coming up is going to be minus. Now what is 2 times a times b?
So a times b is 3x times y times 2.
Yes.
So,
What is that?
that's 6x plus 4 and 4y.
No?
No?
Okay. Well, let's go back a step here. Don't feel bad because this is all new to you. So A is 3x, right? B
Yeah.
is 2y. So I'm looking for minus 2 times A times B. So there's the 2. A is 3x and B is 2y. So when I multiply all of that out, what do I get? What do I get when I multiply that together?
Oh goodness.
Multiply all the numbers.
6
6 times 2, which is 12.
Oh yeah, okay. XY.
Okay.
Okay, there we go. There we go.
And then plus b squared. What is plus b squared in this case?
That would be plus 2y squared, which would be 4y squared. Yeah.
And that's the binomial expansion. So these are the kind of problems you're going to have for the next 3 years, is how to expand a binomial term. And it won't always be a minus b. Sometimes it'll be 3x minus 2y or something. So not having to FOIL it all the time is a huge advantage. And in fact, sometimes they'll ask you, in other words, it's nice to know this in reverse. I saw a problem like this on the SAT. What is this answer?
Okay.
What is that equal to?
Okay, so you've got the 100 squared is...
Don't do it on your calculator. You have to do this by hand. You have to do this by hand. And the answer...
10,000.
No, the answer does not lie in doing the arithmetic. The answer lies in recognizing that this is that format right there.
Oh, so you can just...
Uh-huh. So what is A?
A is 100.
What is B?
B is 99.
So this really is A minus B squared. So it's 100 minus 99 squared, which is?
Well, it's 1.
Uh-huh. So this is 1. And notice that even if you had a calculator, that's not going to be that easy to do. You're going to have to use a pencil and paper and a calculator unless you're awfully good with your calculator. But so, and for the particular, actually this problem was on a GMAT test, which did not allow calculators. So they wanted you to come up with this without having the use of a calculator. And in that case, the only way to do it really is knowing that. All right. What other nice, tough problems do you have?
Let's see. Go over this.
I'll give you one.
It's talking about, I don't know what it's talking about.
Okay.
It's talking about reading algebra symbols.
Okay.
And there's the symbol. Oh, never mind. I got this. Okay. Something important.
What is this? Tell me what that's equal to.
Wait. So don't you add them when they're multiplied like that? So
Uh-huh.
4/3 x to
Yep.
have...
No, just 4/3. In other words, you don't put a coefficient in front of it.
Yeah.
It's not like we have 2 of them, so there's 2 x's there. It's the same base, and you just add the exponents.
Okay.
Same thing if I had x to the 4/3 divided by x to the 2/3. What's that equal to?
X to the power of 4/2. Can you subtract them?
Uh-huh.
Okay.
So fractional doesn't matter. So when you see a problem like this, what's that equal to?
That's equal to x. No.
Rewrite this with an exponent instead.
Wouldn't it be to the negative?
No, Rewrite square root of x without the radical sign. What's another way of writing that? X to the 1/2. In other words, when you use an exponent of 1/2, that's the same as square root of.
Okay.
So that would be x to the 5/2 by just adding the two fractions. And if you want cube root of x, that's x to the 1/3. If you want cube root of x squared, that's x to the 2/3. In other words, when you have a fractional exponent, you're basically saying I'm going to take x to the 5th power and then take the square root of the rest of it, of all of that answer. Or in this case, I'm going to square x and then take the cube root of it.
Okay.
So, here's a classic problem. Do this without a calculator.
Okay. What? So you have 8 to the 3rd square root.
Well, we could word this in a couple of ways. We could say we have 8 squared, we have the cube root of 8 squared, or we have the cube root of 8 and square that. Notice that if we square 8 first, we end up with 64 to the 1/3, which is equal to 4. Cube root of 64 is 4. But there's an easier way to do these. Always do the denominator first. In other words, if you take the cube root of 8, that's 2, and then I'm going to square it, that's equal to 4. Well, what's easier, doing it this way or doing it this way?
The second way.
Yeah, anytime you can reduce the numbers you're using, it's always the better way. In other words, the moment you use bigger numbers than is necessary, it becomes a chance to make errors. Now, with that problem, it wasn't so bad, but if I ask you this, what's the answer to this?
Oh, God.
No, it's easy if you do the denominator first. What's the cube root of 27?
9?
No.
No, that's not. That's
3.
Yeah.
And then 3 squared would be 9. So
Yeah.
9 is the right answer. But notice, if I had to square 27 first, I don't even know what that is, and then take the cube root of that, I would have to have a calculator to do that. I wouldn't know how to take the cube root of whatever big number that gives me. But as long as I do the cube root first, I'm dealing with a very small number, 3. And then I can square 3. So you'll see problems like this throughout the next 3 years of math also. And just always remember, do the denominator first. They're all set up to make it easy to do if you do the denominator first.
Okay.
Okay.
Got put that down. Okay.
I might be getting a little off track on some of this. Why don't you give me more problems?
That's okay. Okay.
Although everything I'm telling you, you're definitely going to need to know, and it's relevant to this particular chapter.
Factoring polynomials.
Okay, let's do some. That's another huge math skill that you're going to need for the ACT, the SAT, and any other math classes you take. So this is a really good thing to get good at, is factoring polynomials.
Okay, so it has 4u to the power of 4 times v squared plus 4u squared times b plus 1.
Really?
Oh, wait. Did I combine them?
No, you gave me the right problem. I just can't believe that that's the degree of difficulty here.
Oh,
All right,
yeah.
I can do this. When you have a problem like this, it's really hard to get a hold of it in your head. And one of the methods we can use is called substitution. Let me just demonstrate how substitution works. I'm not used to factoring quadrat or cortex. This is actually a quartic. But what it really is a quadratic in disguise.
Oh, cool.
And it's hard to see that it's a quadratic in disguise. So let's let x equal u squared. And let's let y equal b. And now let's rewrite this. So we have 4x squared y plus 4xy plus 1. Now, what the heck? Did you read this problem right to me? Did I write it correctly?
I'm like 85% sure I wrote this completely correct. Yeah, that's how it is. See, I told my mom Algebra 2 is hard, and she doesn't believe me. I told her.
Well, here's what this is going to factor into.
Okay.
No, it isn't. Hold on. If I had 2u squared plus 1, and I squared that, it would be equal to 4u to the 4th plus 4u squared plus 1. So that's very close to what you're looking at, except you got a b squared and a b in there. So take a different approach here. And the approach I was taking was trying to turn it into a quadratic. Instead, let's look at it by factoring out some stuff. I factor out 4u squared b. What am I left with? U squared b plus b plus 1. I think that's the same thing. Yeah. Okay, now I can factor out a b, so I should have just factored out a b squared. Gets rid of that and puts a 1 there. So now, does that give me the same term? It does. So that's the way you factor it. And there's no way to factor this further. If that was u squared minus 1, it would be u plus 1 times u minus 1. But the difference or the sum of perfect squares can't be factored any further. So, as far as I can see, that's the best way to factor it. There may be some other magical factor here that works that I'm not seeing, but that's not the typical polynomial factoring problem you're going to have.
Okay.
How about something, let me give you something a little more common, make sure you can do this. Factor that for me. In other words, factoring quadratics. Is this something you've covered this year yet? Or I'm sure you've covered it in Algebra 1.
Nope.
Okay, well this is huge. You need to be able to factor quadratics.
This was the thing with the boxes, right?
Well, yeah, I don't know whether they call it the California method or what, but let me show you how I do it, because I actually prefer the way I do it. I think it's easier and gets you to the right answer quicker. So when we're factoring a quadratic like that, obviously we can't, there's no greatest common factor, because x is not in every term, so I can't just factor an x out. So I have to factor it into two things. Well, this is always going to be, in other words, this times this has to equal that, so that's pretty easy to break up. The next thing we look at is the sign on the number. The fact that that is negative means these signs have to be opposite. The only way you can get a -2 as your final term is if you're multiplying a plus times a minus. Third step, we need factors of the number 2 that subtract, because of that, to the coefficient of the middle term, which is 1. Well, that's 2 and 1. We put the bigger of those factors with the sign of the middle term. So there goes the 2, there goes the 1, and that thing is factored. Notice that if I were to FOIL this out, my middle term, that's going to give me a plus x, that's going to give me a minus 2x, that adds to minus x, which indeed is my middle term. I don't need to check the first term because the way I designed it, I know the x squared is correct and I know the minus 2 is correct. So when you factor a polynomial like this, when you go to check it, mainly check your middle term.
Okay.
Okay? Let me give you another one. What goes here and here?
X and X. I can go that far.
What does this plus sign mean? Actually means the sign is the same on both terms. Because if I had minus minus, that's going to multiply together to give me a plus. Or if I had plus plus, it'll give me a plus. So the way I determine which it is by looking at the sign of the middle term. Since it's minus minus. Now we're looking for factors of 2 that add to the number 3. Well, that's 2 and 1. There's your answer.
And then when you multiply it, it gives you -2 and -1, which is negative.
Right. In other words, minus 2x there, minus x here, add those together and you get your middle term. So that's the fundamentals of factoring quadratics. It definitely can get harder, and it gets harder when the coefficient changes like that. Now, let me just think for a moment here. Yeah, let's factor this. I can no longer put x in x. So what do I have to start with?
You can do 2x and x.
There you go. But now that changes everything, because now I have different coefficients here and here. So I can no longer use those real simple rules that I was just telling you. I can look at the sign there and realize that the two signs have to be the same, and they have to both be minus, so I do know that it's minus minus.
Okay, but then for the 3...
Yeah, hold on a second. I didn't construct this properly. Make that 5. So where does my 2 and where does my 1 go?
So you could put the 2.
The 2 has to go over there, and the 1 there, in order to be able to come up with minus 5x in the middle.
Okay, I see.
See how I'm doing it?
Yeah.
Okay, and that's why we needed a 5 there. If that had been a 3, then I wouldn't have been able to factor it simply. If you cannot factor a quadratic like this, in other words, if you cannot factor it using integers, you have to use the quadratic formula. Have you had that yet? This year?
No, not this year. It's negative b plus or minus the square root of 2 squared minus 4ac over 2a, right?
Very good. Actually,
okay.
b squared minus 4ac all over 2a. Let's go back and stick in a 3. Because when I had a 3 in there, it didn't factor nicely. So if this really was my function, I would have to use the quadratic formula to solve for it. So what is it? X is equal to what?
Okay. So you have negative or positive 3 plus or minus negative 3 squared. Well, I guess that could just be 3 squared too, because it's going to give you the same answer. Minus 4 times 2 times 4 times 4, so minus 16. Okay. Over 8.
2a, which is 4.
Oh, never mind.
However, notice that this is now a negative number inside the radical. So that's where we get into complex solutions like I, imaginary numbers.
Yeah.
So you're probably not there yet either this year. Well,
no, but I've heard the horror stories. So.
Well, don't be scared. They're not that hard at all. Just remember I is equal to the square root of negative 1. As long as you remember that single thing, the rest of it comes easy. In other words, this thing would reduce to, let me just reduce this for you to show how it works. So this is going to be 3 plus or minus square root of negative 7 all over 4. Well, that's 3 plus or minus square root of negative 1 times square root of 7 all over 4. Well, we know what square root of negative 1 is. That's I. So this is 3 plus or minus I times square root of 7 all over 4. There's your 2 answers for that quadratic. And by 2 answers, 3 plus that over 4 is one answer. The second answer is 3 minus that over 4. So you just had a prelim on imaginary numbers. All right. You have any other problems you want to go over, or are you ready to call it a session?
I think call it.
Okay. We've gotten ahead pretty good, I suspect. So yeah. You ought to be well placed for the rest of your classes this week. Or well situated, I should say. Okay. You still there, Sarah? Guess I lost you. Huh. I don't hear you anymore. Okay. I'll talk to you Sunday, and I will talk to your brother shortly. Bye-bye.